All right, so I think I'm recording. We're looking at these semester review problems, and here we have a list of equations, and we're asked to determine yes or no whether the relation is a function in terms of x. And when we first did this, we would solve in terms of y, get y by itself, and then make a table and plug in x values. And if there was ever any x that produced more than one y value, we would claim, hey, that relation is not a function. But then after doing that, we kind of observed a pattern that went on and a little bit of kind of rules of thumb to go by, enough to get us by on these and to quickly answer yes or no without doing all that work. And one of the observations was that although it's okay to have absolute value symbols around the x variable, in fact, that's the absolute value function, it's not okay to have absolute value symbols around the y variable, because if the absolute value of x looks like a v that opens upward, and we know that the vertical line test is a nice, efficient way to determine if a graph represents a function. And if you have that x is equal to the absolute value of y, that v is on its side, and it definitely fails the vertical line test. Where this one passes, this one fails. If you can find a vertical line that intersects your graph in more than one point, it fails the vertical line test and fails to be a function. So anytime that we have absolute value symbols around the y variable, that's going to happen. It may open to the left, or it may be shifted up or down and not be at the origin. But I see absolute value symbols around this y, and I know that that cannot be a function. Now, down here, if I have, well, x squared minus y squared in the second semester, we learned that the graph of this is a hyperbola. We haven't learned that yet, but what we have noticed is the exponent on y will tell us information. If I have, say y equals x, where it's just y to the first power, y equals x is just our identity function. It's a line going through the origin with a slope of 1, a 45-degree angle line. If I have y squared is equal to x, then that's not, y equals x squared is a parabola that opens upward, but x equals y squared or y squared equals x is a parabola that opens on its side, just like the absolute value. Couldn't have absolute value symbols around y. Well, we can't have y squared. It's going to fail the vertical line test. But also, besides that, if we just look at it algebraically, whenever you have an even exponent on y, and you go to, in this case, take a square root because it's being squared. If it was to the fourth power, it'd be a fourth root. But you have to introduce a plus or minus sign because we're taking the square root of a variable, and we have y is equal to negative square root of x, or y is equal to positive square root of x. So for some value of x, we're producing more than one value of y. If we have x is equal to 4, then over here y is negative 2, but over here 4 is related to positive 2. So that fails to be a function because 4 is being related to more than one y value, and that's going to happen anytime you have an even exponent on a y variable. It's going to fail to be a function because it's going to lead to a plus or minus symbol when you get that y by itself when you go to solve for y. So we can just quickly observe, hey, any variable y that has an even exponent is going to fail to be a function. So when I look over here, I see that this guy is going to be a y squared also. So for that same reasoning, since this is even, I can immediately say that this one cannot be a function. Now, for here, 5x equals negative 12. If we solve this for x, this is a vertical line, and if you look at a vertical line, you can find infinitely many points that the same x is related to all of the real numbers. Well, that fails to be a function in the most extreme way. We can find a vertical line that intersects this line everywhere by just laying a vertical line on top of it. So So negative 12 is related to 0, 1, 2, 3, 4, 5, 6, pi, negative pi, 1 billion, 1 billion over 2 billion, whatever, which, uh, never mind. It's related to the entire set of real numbers, definitely not a function. All right. Now, when we go to look at b over here, if we have any odd exponent like y cubed equaling x, if you go to take a cube root of both sides, since it's an odd root, you do not have to introduce a plus or minus symbol, and we just have y is equal to the cube root of x, and we have a function in our library function that's even called a cube root function, and it looks something like that. So we know that when you have an odd exponent on y, it's not going to lead to a plus or minus symbol. It's always going to be a function. So when this guy is odd, well, I shouldn't say always, because if we look over here, this y to the first, that exponent on y was odd, but our absolute value kind of trumped that. If you have absolute value symbols, it's not a function. But if it's missing the absolute value, if you just have y raised to an odd power, it's going to be a function. Well, here we have y raised to an odd power. It's going to be a function. And if you think about what the graph of y equals negative 3 looks like, it's a horizontal line. And a horizontal line definitely passes the vertical line test. There's no way I can find a vertical line that intersects that graph in more than one place. So of these 6, the only 2 that were functions were b and d. The rest were not. And we didn't really have to spend a lot of time. It's focusing on the y variable, and does it have absolute value symbols, or is the exponent on y even or odd? And that's enough for us to determine yes or no whether it's a function. Hope that helps, and I'll talk to you later.